Hello guys, we're given 5.3, says evaluate without using a calculator the sum of cos squared x from 38 degrees to 52 degrees, right? We're given this, we're given cos what, we're given cos squared a, right? There, 52 degrees, then a is equal to 28 degrees, right? So these symbols represent sum. So you know most from your sequence and series, when you have this, you did sigma notation, you're supposed to add that. You'll first, the term that you'll add there, you'll take 38 and replace here, and this will increase by 1 until you reach what, 52 degrees. So you'll simply replace a here. You'll substitute what, 38 degrees plus, remember this symbol represents sum, you go cos squared 39, you increase by 1, and also plus cos squared 40 degrees, and right, I will say to plus, I cannot write all of these, maybe I'll represent like with the dotted, this dot represent that there are values there. Then I will say also here plus, I will say cos can say cos squared what, 50, right? Yeah, or 50, or I can say 50 plus cos squared 51 there. Let me do like this, squeeze it a bit. Right. You want me write accurate plus here plus cos squared 51 plus cos squared 52. So what we have, you see how I've expanded. So we have squared, right? Then you're supposed to add these, all of these you're supposed to add. So there's something interesting here. I want you to check something here. Check. For argument's sake, let me add the first and the last. I want you to check. If I add there, check. I want you to check something. Let's say I add this one with the last one. I want you to check something there, the pattern there. Check the degrees. You have 52, you have 38. You can simply say 38 plus 52 gives you what, 90. You see, these are co-function. You can change one of the two. Okay, for summary, if you have sine, for argument's sake, sine 30 degrees, this is the same as what? As cos 70, is cos 60 degrees. As long this angle adds up to what? To 90. This will be co-function. Right, these things are exactly the same. If they add, sine 30 is equal to that, right? So cos 45 is the same as sine 45 degrees, right? You can change this. So let's say now you're given something like this. Let's say you sum up sine with, for argument's sake, let me say sine 31 plus cos, I can say cos, for argument's sake, 59. This angle adds up to what? This angle, they add up to what? To 90. Then you can change one of the two. It's either you change this, because we said they're the same, is either you change this to become sine 39 or you change this to become cos 59, because those are co-function. You can change one of the two. You can say this can be equal. You can change, maybe you can change that. If you want to change, would be cos 59 plus cos 59, right? So this, you apply co-function, or you can look at this in this perspective. For example, 39, right? You can look at this perspective. Let's say you can say 90, right? Then you say minus 38. So this, you see, right, it's a co-function. This is positive in the first quadrant. It will give you what? Sine what? 38. For no, sorry about that. Oh, what I'm doing is so wrong. I want, okay, for argument's sake, 90. You can say I want us to have that 39. 90 minus 52 will give you 90 minus 52. You're supposed not to change this. Remember, 90 minus 52 is equal to 38. So we have not changed anything. But however, if you look this at this perspective, 90 is a co-function. However, this will change to towards positive sign. Then you take that, this can replace it, is like can represent it, and then you will have 52, right? So you see the what, if you look at this perspective, you see, so what we'll get there. So what I'm trying to say, as long they adds up to 90, change 1. 38 plus 52 ends up to 90. So I want you to check. We took the first one and the last. You see there. And then let's check. It's a first. Let's come to this one, to the second one. I will add up to the last second. You see, I will add up to the last second. Check that 39 plus 51 degrees is how much? This 51 degrees will give us what? 90. So you see the pattern. On and on, 40 plus what? Plus 50 is what? Is 90. You see the pattern. You take the last, you add the second, and like this. You see the pattern. However, as you check, there must be a middle value here. There will be a middle value that won't add up with nothing. Imagine, for argument's sake, imagine if you have a patterns like this, you have a sequence. For example, you have a sequence or a sum. Let's say we have 1 plus 2 plus 3 plus 4 plus 6 right? As you can see, then I say add this number like the way we've used. Let's say we took you add this, the first and the last as I did there on the top, you add this yet 2 with that. You see you left with what? With the middle value. That middle value is what? Is 3. You see, so here we'll have a middle value here. That middle value you must know, you must be curious what will be that value. That value definitely will be the value that it's it that value when we add it that does not cannot will exceed is the value that we can add this side that will exceed what will exceed 90. Imagine this dotted represent these things continuing. Here you'll have 41, then this side will decrease, we'll have 49, we'll have 42, this size will decrease, we'll have 48, 40, 43, 47. Yeah, well, you see what is going on. 43, you'll see 47, 44, 46, but 45 cannot add up with nothing. That means this value here will be cos 45. The value there in the middle here, this value here will be cos squared 45 degrees. Do you agree with me? That value here will be 45, isn't it? So for the argument's sake, since you have added like that, we know I've said those are cofunctions, they will change, right? So we can change n. Let's change there. We know that here we'll have 45 here. Let me just show it. You see, here we'll have 45. So I can change here. I can say this. I can say this. I can say equal here. No problem. I saw this will add up with that. This will add up with that. I can change one of the two there. What I can change between this and this, maybe I can say bracket, then I can say cos squared. Let me change what? Okay, let me leave this one 38. Then I say plus. Remember, this will change. It's a cofunction of this. The cofunction this will change to be what? Sine squared what? 38. The angle adds up. As long the angle adds up to 90, you can change one. You can change the angle to be the same, but you change one. You only change one, and then you change the trigonometric ratio. Change from cos to sine, right? So also I can say plus. Then I come with this, and I take this. I can say 39. 39 plus cos squared 51. Okay, I can say cos squared 39. I will decide to change that. That will be sine squared. As you can see, sine squared 39, right? Isn't it? So here brackets plus again, as you can see, plus again what? There we'll have cos squared 40. Then I add that. I can add these two. So cos 40. Then I can add. I said cos 40 to 51, right? Well, cos 40. Okay, cos 40 to 15 to 50. cos 40 to 50, I can change this 50 to become cosine. That will be sine what? Sine squared. I changed to become what? 40. You see the pattern, right? Plus, you see, until you can check there, we have 52 minus 38. You see there, it goes like that until yeah, this thing you just follow this pattern until you end up to the value you're supposed to end up, right? Those values. So this is what we have. You continue. This is 40. I can just leave this one. Let me just, if you like, you can show, all of them. If you have time, maybe you can say, but now, okay, you can say bracket again. If you want, you can say, you see the pattern will continue. You see 38, 39, 40. That means here you can have 41. If you want to continue, 41 plus sine squared 41. You see, until if you want to continue until you reach what? Yeah, until you reach 40. Okay, but this okay, we can continue until 45. There's no problem. You can continue. You can say plus again. You can say cos. There will be what? 42. You see, most the pattern squared plus sine 42 squared. See the pattern cos 43, you see, squared plus sine 43 squared 43 squared plus, as you can see, the pattern cos squared 44 plus sine squared 44, right? But the middle term is what? You'll see plus cos squared 45. Remember, I've said here will be 45. That will be what? Our last. So as you can see, ladies and gentlemen, what is this? Simply equals to 1. Remember the law, sine squared theta plus cos squared theta is equal to what? To 1 when the angle are the same. So ladies and gentlemen, this is 1. This we will have there, as you can see. Here we'll have 1. Here we'll have 1. You'll have 1. You'll have 1. All throughout you'll have 1, 1, 1, 1. Let's count those 1. You can say equal. Let me write this out first. You can have 1 there plus the second one plus here it's 1. Also here you will have what? Plus 1. So far it's 1, 2, 3, 4 ones. You come here, we get what? Plus 1. You come here, you get what? Plus 1. Come here, you get what? Plus 1. You have 1, 2, 3, 4, 5, 6, 7 ones. Right, then here the last one is 45, which is it's a special angle. So 45 squared, right? It's a special angle. I hope you know your triangle, right? Isn't it your special angle? 45 here. 45, it's 1 square root 2. So this is adjacent over hypotenuse. It's 1 over root 2, right? Yeah. So we can use that. 1 over root 2 will be plus 1 over root 2. But remember, there is a square there. You square that thing there. So ladies and gentlemen, we have 7 ones here. You add them. You're supposed to get that is equal to what? To 7. Then here we apply your math. This will be same as what? Remember, 1 over this thing is the same as 1. When you square that, you still have, you'll say squared. Then you square the square root. You apply the law. Remember the laws of exponents. If you have a, b, c, right? This will be a raised to the power of c, also b raised to the power of c. So you can use that there. Then here you'll have 1 over root 2. Then you square this. When you square there, this will be equal to 1. Remember, there is not 1 raised to the power of 2 is still 1. Then you square this. Square root will cancel with the square. Then you're left with 1 over 2. So ladies and gentlemen, as you can see there, we have plus 1 over 2. So 1 over 2 is either way, which one you prefer. There we have 2. It's up to you which method you want to apply. Since here we have 1 over 2, you can say over 1 and multiply, make the base to be the same. You simply have 7 plus 1. You simply have 7. You'll have 14. When you multiply there, we have 14 over 2 plus 1 over 2. As you can see, denominator is the same. You add the exponents. You add the numerator. You have 15 over, what is that? 2. So we'll have 15 over 2. So in mixed fraction, you can write this. Also, this is the same as 7 1 over 2. Remember, the mixed fraction you're going to remember, this is the same. How we can show, you will multiply 7 by 2, you will have 14. Also, you add down the top, you add 1, we will have what? 15. So it's either you use this as a mixed fraction or you leave your answer here. This is the one and the same thing. So guys, thank you, and then do not forget to subscribe. Please do not forget to subscribe. Don't forget to subscribe. Right, don't forget to subscribe to my YouTube channel. Stay blessed. Thank you for your time.